All right. So, so here's a question. Function gives C gives the cost the bakery produces, and the cost is in dollars. The function M is defined by that thing, gives the marginal cost in dollars to produce cake numbers X plus 1. Which of the following gives the best estimate of the marginal cost in dollars to produce the 40th cake? So if you look at this one, let me make sure that I have that right. Got people dropping off like crazy. So when I think about like this problem, producing the 40th cake. So we think about producing the 40th cake. What we'd have is this kind of a question that you got to kind of back up and think about what we would have on this. And if you think about like the 40th cake would be if we put in let me think of how I can explain this best. So to produce cake number, so this marginal cost to produce cake number X plus 1 would mean that that you take the 40th cake minus the 39th cake. Does that make sense? But then you'd have to divide it by, when you think about like what that means, I'm gonna put it down here. So if you take the 40th cake minus the 39th cake divided by 40 minus 39, you're talking about like you're talking about the slope here, right? If you think about what that is, that's another way of doing the derivative of the 39, right? I mean, it's the idea of when you're using this marginal, this equation right here, and you do C of 40 minus C of 39, but then you divide it by 40 minus 39 because that's that extra cake there. That then you're getting you're essentially talking about the slope. You're just doing the derivative. And so then you get that's the same thing as doing C prime of 39. So the cost of producing that next cake in economics, that's called the marginal cost, is what that's called. Maybe that was a little bit trickier than what I would have wanted, and I don't know if I answered that. Does anybody have any questions on that? On why it's that answer?
Wait, so how is that formula they show, how is that the slope?
Well, they don't use this formula. What they do is they do they do m of 40 is really equal to c of 40 minus c of 39. But then if you do c of 40 minus c of 39, and you divide it by 40 minus 39, which is just 1, right? I mean, 40 minus 39. This is another way of doing the slope. And it's really sort of equivalent to c prime of 39. I mean, you could say that isn't that equivalent to c prime of 40? And I'd probably say, yeah, it's probably equivalent to c prime of 40 as well, but c prime of 40 isn't an answer. But this is just y2 minus y1 over x2 minus x1. It's just another way of identifying that that's the slope.
Yeah, but why are you dividing it? I'm still not up.
Either way, this is just equal to 1. So it's the cost of producing one more cake, right? I mean, it's a tricky way to think of how that's 1, and that's simplified, but it's the same. The marginal cost of 40 is equal to that. I mean, it's kind of tricky, right? I mean, that you'd have to identify that that's 40 minus 39. So that's 1. So the denominator is 1. It's kind of another way of writing the slope, which is really just c prime. So generally speaking, in the step diagram, if cost is here, marginal cost is here. In an economics model, that's what's true.
What is marginal cost?
Marginal cost is the cost to produce one more thing. Like if you were a t-shirt manufacturer or something like that, and you sold 200 t-shirts, and you want to know, well, how much more is it going to cost me to produce one more? That would be the marginal cost. The marginal cost is the dollars. It's the rate of change of the cost. So I don't know if I could put a unit on it, but if cost is in dollars, it might be in dollars per shirt or something like that. It's the cost to produce one more thing. So eventually, like in an economics model, like if you have a big plant that makes cars, eventually your plant can't handle making more cars, and you have to get a bigger plant. Well, you're looking at the marginal cost to figure out when you need to make that change to get a bigger plant, because you've overgrown your resources in a certain plant or something like that. And that's where an economist might look at the marginal cost for that, where it might not be cost effective to produce anything more.
I'm confused, like where is 39 coming from when we're talking about the 40th cake?
Well, it's kind of it's right in here. Let me highlight it right there. So the marginal cost to produce the 40th cake would be 39 plus 1. And that's this part right here, that's 40 minus 39. So it's kind of wordy in there. And so I think that's a pretty tricky, wordy question in there. Honestly, I think that's a little bit tricky the way that's worded in there. Let me look at number 5. So let x and y be functions of t, such that sum of x and y is sum of x and twice y is a constant. So if you were to write that out in words, the sum of x and twice y is a constant. Does that make sense? That first line would be written that way. Is everybody okay with that? So then it says, which of the following equations best describes the relationship between the rate of change of x with respect to time and the rate of change of y with respect to time? So they're saying, okay, now that you have this, differentiate with respect to time. Well, if we differentiate x with respect to time, that would be dx dt. If we differentiate 2y with respect to time, that would be 2 times dy dt. And if we differentiate that constant, we would get 0. And then you just move it over, and that's why B is the answer. But the key is, can you write this? Oops, can you write that in terms of an equation? And if you didn't know what the constant was, you can put the constant and put your favorite number in there, 23, and then do it off of that. Let's look at 6. So the volume of a cone for some of the radius and the height is given. So they give you they give you the volume. The rate of the change of the radius with respect to time is 6. In terms of r, what is the rate of change of the volume with respect to time? So when you think about that one, we got this volume equation, which is 1/3 times pi, which is just a constant, times r squared times 10 minus r. I might, if I were doing this so I didn't have to use the product rule, I probably would write this as actually, I'm going to do it this way. Let me think about the best way I'm going to do it. Yeah, I'm going to write it this way. I'm going to write it as 10 pi over 3 r squared minus 10 pi over 3 r cubed. If I take this and distribute it there and there. If I do that, simplifying first on that volume equation, I don't have to do the product rule anymore. And I'm going to have to simplify somewhere. I think that's good. That's where my bias would go. Now I'm not going to have to simplify the product rule. Now I just have to differentiate this, where dv dt, which is what I'm supposed to find, right? I mean, that's the question. So dv dt is equal to 10 pi over 3 times 2r dr dt minus 10 pi over 3 times 3r squared dr dt. Does that make sense, what I wrote there? Okay, so they also gave me on here, they said dr dt is equal to 6. And they say write this in terms of r. So all I'm doing now is, I already know that my answer is going to be C, D, or E based on that r squared and the r in there. All I got to do is I got to do a little bit of arithmetic on here. And this is where the multiple choice is different from the free response. Because if it was a free response question, I would end up writing my answer like that. But the free response question doesn't allow, I mean, I don't get to do that on this, right? I can't, I don't get that luxury on this one. But I know that this is R. This is 10 times pi times 2 times 6 divided by 3 minus 10 times pi times 3 times 6 divided by 3 r squared, and I just have to simplify it. And I can kind of ignore the pi because the pi's in both of those. So I mean, technically, it might even be easier if I took that pi and wrote it right here. And then I just have to simplify those things. But I did mess up a. What did I mess up on?
I think you brought in the 10 in the second half of the equation, so it should be.
Oh, I sure did. I didn't want to bring the 10 in there. I didn't want the 10 there, or there. Yeah. Because the 10 should just go with, the 10 should just go with the first piece. Okay? But multiple choice, you get the luxury of having an answer there for you. Any questions on that? Okay, 7. So a cube has a volume of edges of length x of t. The volume of the cube decreases at a rate proportional to its surface area. The volume of a cube decreases at a rate proportional to its surface area. Which of the following differential equations best describes the rate at which the volume of the cube decreases? So if so that we got to unpack what that decreases at a rate proportional to the surface area. What that means, so it says, V of t. So you got this cube. Let me draw that out first. You got this cube that each side is some function x of t. So the volume is equal to x of t cubed. And it says the volume of the cube decreases at a rate proportional to its surface area. The key on that one is I'm trying to figure out the best way to describe it. So the surface area of this cube is going to be if I had just this thing, it would be, there's 6 faces on that cube, each having x of t squared as its equation. Does that make sense? What that is? Now, if you decrease at a rate proportional to the surface area, if the volume decreases at a rate, so it's saying dv dt decreases, which that's going to be where that negative comes in. You don't really, if you miss the negative in there, it really wouldn't matter because there was a negative in every one of the answers, but that's where the word decreases comes in. If it was at a rate proportional to its surface area, it would be k times the surface area, some value k times the surface area. That's how you would, and k is a constant of some sort. Well, if you think about what that is, there's only one answer that has x squared in it, right? Well, there's an x squared with t, but that t is a different t, right? I mean, this is a function as with respect to t. So this one is actually x times t. That's different. See, in this problem, x is essentially equal to x of t in this problem because it's just saying it's a function of t. where C, the difference is, so A is negative 1.2 x squared. C is negative 1.2 x squared times t. Those are different equations. Those are different. That t is not a part of it anymore. Like, I don't get to distribute this squared through to here and here. That's not part of it, because that x of t is just a function. Does that make sense? Okay. Then let's go to number 9. So right away, you should think some kind of Pythagorean theorem, some kind of trigonometry, something, because it's making a right triangle. That's instantly when I see this, I'm going, okay, this is a right triangle. I get to use anything that I get with a right triangle. Maybe I'll use an area formula, but that's where my bias would go, right to there. So if I draw this out and I start thinking about the pieces that I have on here, I have this picture that looks something like this, and it's a 15-foot ladder. Now it's a ladder. So what is dc dt?
0.
Yeah, why is it 0?
Ladder does not change length.
Yeah,
Unless
because
it's
if the
one of those,
ladder
like,
changes
extended
length,
ones.
that would be really bad, right?
Unless
That
it's
would be a
an
really
extended
bad
one.
thing to happen to you. The ladder rests against the wall. The ladder is sliding down the wall at a constant rate of 2 feet per second. So the ladder is going this way. If we call this B, dB dt is actually equal to negative 2 feet per second. Now it's negative because it's sliding down the wall, right? That length B is getting shorter each time. At what rate in radians per second is the angle of the bottom of the ladder and the ground changing at the instant the ladder is 9 feet from the base of the wall? So so at that instant, the question is, what is that value right there? Does that make sense? It's actually asking you, what is that's the question it's asking. Does that make sense? Okay. So on here, we can get some different information, and then we can use trigonometry to solve it. But I would love to know what B is. Well, I could find B, because I could do 15 squared is equal to B squared plus 9 squared. And I don't know what that comes out to be. It's probably a Pythagorean triple, right? So it's a 3, 4, 5. So it's 12. Is that right? I think B's 12. Okay, so B's 12. So what I'm going to do, if I can, I'd love to use the ladder as part of my length, because that's not changing in this problem. But so in order to use that, and I don't really know anything about dA dt, so that's going to be really tricky. So I'm probably going to use this side and this side with that angle. Well, if you think about that angle, this side is the opposite side. This side is the hypotenuse side. So which one am I going to use? I'm going to use the sine, right? Does that make sense? So I'm going to write the sine of theta is equal to the opposite side divided by the hypotenuse. And now I'm going to differentiate it. And I'm going to say, okay, well, if I have to differentiate this, the derivative of sine is cosine. but I also have to differentiate theta with respect to time. I'm going to use the quotient rule on the other side. So I'm going to do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Does that make sense? I have everything I need to know. All I need to do is I need to go through and calculate and write this out. Now, one of the tricks that you have to realize is the cosine of theta is actually equal to 9 over 15. Do you guys see that the cosine of theta is 9 over 15? So if the cosine of theta is 9 over 15, then I go 9 over 15 times d theta dt is equal to 15 times negative 2 minus 12 times 0 over 15 squared. Does that make sense? And now I fortunately get some really convenient things to happen because I got 9/15 here. And I got negative 2 times 15 over 15 squared. And that means d theta dt is equal to negative 2 times 15 over 15 squared times 15 ninths. And I would encourage you on the multiple choice, especially when you don't have a calculator, to not do a lot of multiplying out. Like I know 15 squared is 225. But if I start multiplying that out, I'm going to have to multiply a bunch of things out. And generally speaking, the arithmetic that they give you on the AP exam is going to be stuff that you get to just reduce. Like this 15 squared goes with those two 15s, and that's why you get negative 2 ninths. Okay. Everybody okay with that one? Okay, let's look at number 10. And I got 10 minutes left. So this one is the same kind of thing, only this one is, I mean, it's really the same kind of problem, only this one you got a 25-foot ladder. It's sliding down a vertical wall. At negative 3 feet per minute. When the top of the ladder is 7 feet off the ground, what is the rate of change of the distance between the bottom of the ladder and the wall? Intuitively, which answers do you get to get rid of and why?
The negative ones,
Yeah, why?
because as the ladder falls, because of physics, I guess, the ladder will get further away from the wall.
Exactly. The ladder's got to be going this way. If the ladder's going this way, the top's going down, the bottom's got to be going out, which means if the top's going down, the bottom's got to be going out. So negatives don't matter. Now, if you do that, suddenly you got a 1/3 chance of getting it right. Now, on this problem, you do have to come up with A, and that's probably another Pythagorean triple, but I don't remember what that is. It must be 24. Is that right? No, is it 24? So A is
Should.
24.
Yeah, it's 24.
Yeah. So now we're asked to figure out what d/dt is. We have everything we need to know on this. Why? We have a squared plus b squared equals c squared. These are just like the problems that you had on delta math, or 2a dA dt plus 2b dB dt is equal to 2c dc dt. So unlike the last one, it's the same kind of diagram, but this one uses the Pythagorean theorem. The last one used trigonometry. Pretty common to get one of those two things. But those negatives mean something. So make sure you, like if I lose the -3 because it's sliding down the wall, that's gonna, I'm sure one of those answers in there is the answer without the -3 in there. I just don't know which one. Okay. Any questions on that before I move on? Okay, let's see if I can go a little faster. F is differentiable. So I know this is one thing I can't stand about AP Classroom is I think this is the information they're giving me. If the tangent line to the graph at x equals 3 is used to find an approximation to a 0 of f, that means we're trying to figure out when f is equal to 0, that approximation is. So if you don't interpret that right, you're going to be in trouble. So if I take these two things and I write the tangent line, then f of x is approximately equal to 5 times x minus 3 plus 2.
Mr. Ahlquist, I don't know if this is just me, but when I was going through and doing these problems, it looks like it said f of 3 is equal to 2 and f of 3 is equal to 5. Like it was very unclear
Yes.
how with the derivative.
It's really hard to see. And I wish I could, so I mean, I agree. And that's one of the tough things. I just noticed, I mean, like when you zoom in or when you look at the f of, you couldn't, it wouldn't be, so here's the reason that couldn't be true, is if f of 3 equals 2 and f of 3 equals 5, it's not a function. Right? But it tells you it's a function. So that wouldn't make any sense to have them both equal 5. That's the best I can tell you. The other thing is, right, when you look right there, that f with the second f looks different than the first f. And I wish their stuff would be better. And I don't know if I zoom in, you know, if I, how do you zoom in? I can't remember how you zoom in on here, but if you zoomed in, maybe you could see it better. That would be my only thought on that. I know that that's hard and I wish it wasn't, but that's what I got to work with without typing them all out again. But do you guys understand the concepts behind that problem? Because now you just do this and solve it. Let's see, 12. Same kind of thing with this one, I guess. And this one's even harder to see, I think. That's super hard to see. I'll look back and see if I can see if there's any, because I'm guessing that this one is the derivative. But boy, is that hard to see. So let's not do that one. But I think that this one is the derivative. I think that on this problem, they're probably working it where f of 2 is equal to 4 and f prime of 2 is equal to -1/2. So then use the tangent line for f of 1.2. That would be my guess. I know that's hard to read. I mean, I can't help you with that. Other than I'll look at the test to see if there's anything that's like that. I don't think there is, because I think I took that into account. But that's the equation you would use, and then you would put in 1.2. Or 2.1, sorry, 2.1. Okay? Can I move on? Because I got about 2 minutes to get through one question. This one's a little easier to see. I think this is the second derivative and this is the first derivative, but it's the same kind of problem. I think this problem is saying f of 2 is equal to 1, f prime of 2 is equal to 4, and f double prime of 2 is equal to 3. And so f of x is approximately equal to 4 times x minus 2 plus 1, and then use 1.9. Okay.
I have a quick question about the however you say it, L'Hôpital, hospital's rule, those ones.
Yep.
So when you apply it and you still get 0 over 0 or infinity over infinity, do you just keep going or do you stop?
Keep doing it. Do it again and again and again.
Okay, because I know there was one that was like.
Take this one right here.
Yeah, that was the one I was actually thinking about.
So I'm not going to write the limit because I don't have enough time right now. But know that I'll actually write it the first time. That's infinity over infinity, right? So you take the derivative of that and you get 3x squared over e to the 3x times 3. And that's still infinity over infinity. Differentiate again, you get 6x over e to the 3x times 3 times 3. That's still infinity over infinity. Differentiate it again, you get 6 over e to the 3x times 3 times 3 times 3. That's 6 over infinity, which is equal to 0. And then if I go back up and write these in there. Now in the multiple choice, I don't have to establish that the top and the bottom are in an indeterminate form on because I don't have to show my work on a multiple choice. But that's the way you get 0 on that. So I just kept on differentiating. And shoot, let's say you screwed up the chain rule on this and you never did the chain rule. So let's pretend you bumbled the chain rule and all you wrote was this each time, you'd still get the right answer. Right? I mean, if you'd still get the right answer because you still end up with 6 over e to the 3x, which is still 6 over infinity, which is 0. So those powers of 3 wouldn't matter on this one. On the multiple choice, on the free response, you'd get it wrong, but on the multiple choice, you wouldn't. Any questions on that? All right. Then that's it. Have a good break.
Thank you. Bye.
Thanks, Ahlquist.
See ya.
Thank you. Or actually, Mr. Ahlquist, I have a quick question. So like for that last one, like when you're doing the limit as x goes towards infinity, like what are you technically like, like for the first one, like how are you supposed to solve for that? Like what do you plug in for the x's to get 0 over 0?
You don't get 0 over 0, you get infinity over infinity.
So like anytime there's an x on it, you just automatically get infinity?
In that case, yeah. Yeah, because when you put infinity in there, you get infinity.
Okay.
Right?
Sounds
So you
good.
get infinity over infinity. So that's the other indeterminate form that is on that we have to account for.
Okay. Sounds good. Thank you. Have
All
a good
right,
one.
see ya.